All right, folks, so for Electrostatics 5, we're back to methods of charging, and our second of three methods of charging is charging by conduction. Charging by conduction is the most straightforward because you just touch the objects together. So when objects are in contact, they will exchange electrons according to some of the rules that are here. In order for charging by conduction to happen, the objects have to have different charges to begin with. So if two neutral objects touch one another, then nothing will happen. If two objects with the same amount of positive charge touch one another, nothing will happen. And then same with the same amount of negative charge. So the objects have to have different charges. They can be like positive and negative neutral. They can both be positive, but different values. As long as the charges are different at all, then this will work. The end result is always that both objects end up with the same charge. So no matter what they started with, they have the same amount and same sign of the final charge. The rule that governs conduction is that electrons always flow to the more positive objects. So the philosophy for that is that electrons are negatively charged, and so they are repelled by other electrons. So if there's a negative object and a positive object, then when they touch the negative object's electrons will move into the positive space. They will spread themselves apart as much as possible, and if there's another object that they can go into, then they will do that. So we're just going to make some drawings. That's really all the notes. We're just going to make some drawings to show what happens in a couple different situations. Now, I'm going to have a color-coded drawing here. I'm going to use red and blue. I think the blue is going to show up okay for this. The red definitely will. So our first example is two objects, A and B, where A is initially negative and B is neutral. Now, we're going to use this as a bit of a review. I'm going to draw some plus signs in here. Now, these plus signs are evenly spaced, and they represent the protons in object A. Now, there's billions or trillions or even more protons in an object, even if it's super tiny, but we're going to draw 5, just as a representative. We'll say there's like 5 trillion protons in object A, and there are 2 trillion protons in object B. So it's arbitrary. You can pick any number you want. I'm just using them to represent all the protons. So A is negative. An object that has a negative charge has more electrons than protons. So if I drew 5 protons, I'm going to now draw 1, 2, 3, 4, 5, 6, 7. 7's pretty, we'll do 8. 8 negatives, and those represent the electrons. Now, obviously, they're not just sitting there. They're zipping around at like almost the speed of light. But in this object, there's more negatives than positives. So we'll say, okay, there's 5 trillion protons, and there are 8 trillion electrons. B, however, is neutral. So if there's 2 pluses, there has to be 2 minuses. And so that's it. I have a negative object that has more electrons than protons, and I have a neutral object that has the same. The during part, I'm going to be very simple about this, and I'm going to switch to black ink. A is negative, B is neutral. That means that object B is the more positive object, and that's important. So B is not positive, but it is more positive than A. So A is the most negative, B is the most positive. And so all I want to show in the during part is, well, electrons always flow to the more positive object. So I'm going to draw an arrow. It's going to start in A, it's going to end in B, and it's going to say electrons. And that's it. So that's the process. Now I have to play a little game. The end result is that objects end up with the same charge. So we're going to take this slowly at first. The number of protons doesn't change. So protons, when objects are touching one another, protons don't move around. They just stay. They stay in their atoms, in the substance they belong to, and that's all there is to it. So A and B end up with the same amount of positive charge they started with. Now I have to be careful. objects end up with the same charge. So ideally it's supposed to be like the same number of charge. We're not going to be able to do that because I made a silly decision here, but that's okay. So A was negative, A lost electrons, B was neutral, B gained electrons. So no matter what, B has to be negatively charged at this point in time. So bare minimum, there have to be 3 negative charges in B at this point in time to show that it gained at least 1 negative charge. I'm going to go with that because what happens is I move some electrons over to B. So we'll say I moved 1 trillion electrons over to object B. That means I have to take 1 trillion electrons away from object A. It started with 8. It's now going to end up with 1, 2, 3, 4, 5, 6, 7. And so it's a very subtle change. Probably could have done a better job picking numbers, but to summarize, this had 8 electrons, and this had 2 electrons at the beginning. And in the after section, this has 7 electrons, and this now has 3 electrons. Now, they obviously don't have the same number of electrons, but they have the same approximate charge because object A always had 5 electrons, and object B always had 2 electrons, or 2 negative dots, or whatever. So A was negative, B is neutral. Then the electrons move, A is still negative, and B is now negative. And so B now has charges. Now, we're not going to do too much drawing in this unit, but I wanted to do it here so you could see some of the decisions we make. What's important is knowing that once you know that A is negative and B is neutral, you know the electrons are going to move from the negative object into the neutral object. Okay, next example. I'll do this one a bit faster so you can just kind of watch and see. We'll start with the same number of positives. So 5 and 2, and because I know what's going to happen, we talked about it, I'm going to keep the 5 and 2 positives there. So now this time A is positive and B is neutral. So the B is neutral part is easy. I can put the same 2 electrons in there that I want. And so I'm going to have to make a decision here, but what I'm going to do is I'm going to make A like very positive. So we're going to just put 2 electrons in A. So now like the positives outnumber the negatives, which means A is positive. So that's my before picture. So based on what I have a positive substance and a neutral substance. Now, the rule again is electrons always flow to the more positive object. The positive object here is more positive than something neutral. And so when those 2 objects come into contact, the electrons move into A from B. So even though they have the same number of electrons, A has a lot more capacity to receive electrons. I mean, physically this time it's because it's bigger, but really what's happening is it has a positive charge. A very positive charge always welcomes electrons. So B transfers something over, and I'm going to have B transfer 1 of its electrons over. So B is going to be left with just 1 negative, and A at this point in time has 3 negatives. So A and B are both positively charged at this point in time. So A has 5 positives and only 3 negatives. B has 2 positives and only 1 negative. So when you charge by conduction, everything ends up with the same charge.